Okay, well, I hope everyone had a good holiday weekend. Celebrate Independence Day and whatnot. Let's see. So this coming Monday, we will have our midterm exam. Okay, so Monday, July 11th. That'll be our midterm exam. And so we'll cover chapters 1 through 6. Okay? It's all multiple choice. You'll have 1 hour and 45 minutes. Okay. It'll be a mix of conceptual and calculation questions. Okay. Okay, and it'll be right here in this this classroom. I think there's enough seats for everybody to space themselves out, so there's at least one open seat between you and your neighbor. So when you come down, when you sit down, please make sure there's at least an open seat, one open seat between you and your neighbor. Okay, any questions? Yes?
Do we have to bring our own Scantrons?
No, I will provide the Scantrons for you. Today's Wednesday. Okay, other questions? Yes? Is there still a lab that day? Wait, what's that? Is there still section? Yes, yeah. Section is still scheduled. If you're in the 2 o'clock section, I give you permission to attend an earlier section, but don't all go to the 10 o'clock section because there's not going to be enough seating. Okay, so if you're in the 2 o'clock section, I give you permission to attend the section that comes before. Okay, because that section will probably serve as kind of like a last minute, you got questions types of thing. So if you're in the 2 o'clock section, you can go to an earlier one, but please be respectful of the students who are enrolled in that section, and don't kind of crowd them out of their seats. Okay. Anything else? Yeah.
Roughly how many questions are we gonna have?
Roughly how many questions? Probably in the vicinity of 50 questions. Okay, something around there. More or less. Okay. Generally, the way I try to figure out the appropriate amount of time is I write the exam and then I take it myself and then I give you guys a factor of 6. So I take the time it takes me and I multiply it by 6, and if that's less than an hour 45, then I figure it's a good length. Okay, so basically, if I can finish the exam in like 16, 17 minutes, then that's how I kind of gauge it. Okay, but I mean that's because I know exactly what I'm doing, right? So So anyway. Okay. It should be, I imagine the length of the exam will be fair for most of you, okay? All right. Anything else regarding the exam? I'll have office hours today from 2 probably until around 4 o'clock-ish, so I'll have a little bit of extended office hours times. It's going to be mixed in with my other class, but today I'll have office hours from 2 to 4. So if you have any questions about anything, come by. Great. Yeah, it's summer. I don't intend to for the class to be burdensome, but we are trying to fit a quarter's worth of stuff into basically half the time. All right, so let's. I want to just wrap up a few things from Chapter 5's probability. Okay, so just a bit of Chapter 5 probability wrap up. Okay, and then we'll get into Chapter 6 where we'll make use of the table I just passed out. Okay, so we left off, I think, talking about probabilities of sequences of independent events. And we said something like the probability of A and B is equal to the probability of A times the probability of B as long as A and B are independent. And we said this can be extended where if we have, the probability of A and B and C and so on, this is going to be the probability of A times the probability of B times the probability of C, okay? As long as A, B, and C are independent of each other. And what does it mean to be independent? To say that two events are independent means that yeah, that's correct. The outcome of one event has no influence on the outcome of the other event, okay? So let's say you go to a casino and you're going to play roulette, okay? All right. And so if let's say you bet on red. You can bet on even and odds or whatever. So let's say you bet on red and you're going to play roulette. Then, at least in the US, your probability of winning is 18 out of 38. Okay, do you guys know roulette? Maybe some of you yes, some of you have no idea. Okay, so roulette is the one where you've got the wheel, and then and you've got all these different little. There's 38 squares, okay? And there's like 2 that are green, and everything else is red or black. Okay. Oops, that's not. What's going on here? Okay, so yeah, so two of the spots are green, and then everything else is red or black. Okay, and it's the game is set up in such a way that the casino always maintains a small edge in winning. Okay, so you know, betting on red will pay out evenly, but the probability of winning is not 50%. It's 18 out of 38. Okay, so you've got so 18 over 38, and you get, you know, you got a 47.474% chance of winning. Okay. All right, so I can ask a question like, if you play 3 games, you know, what is the probability you win all 3? Okay. So what is the calculation that we would do to get this answer? So this would have to be probability of win, followed by win, followed by win. And this is going to be 0.474 times 0.474 times 0.474. Okay, or also 18 out of 38 raised to the 3rd power. So whatever you want to do. Okay, so I'm going to just take this answer, raise it to the 3rd power. Okay, and because, you know, 0.474 is rounded or a little bit, it's, the answer is 0.1062. So it's a little bit different. Oh, 0.10628. Okay. All right, something like that. Okay, that's the probability of winning all 3. Is that good? What if I say you play 3 games? What is the flip to the next slide. So we'll say, so we're still going to play roulette, and we'll say, you know, bet on red has a, you know, probability equal to 18 out of 38, or 0.474. Let's say you play 3 games. What is the probability you lose all 3 games? So what would we have to do here? So this would be probability of lose, lose, lose. Okay. Probability of losing 1 game is going to be what? 1 minus 18 over 38. Okay. And we're going to raise this to the 3rd power. Or you can do 20 over 38 to the 3rd power, or equivalently 1 minus 0.474, so 0.526 raised to the 3rd power. And you get 0.1458. Okay, so you can see the probability of winning all three games is, you know, significantly lower than the probability of losing all 3 games. And you know, so this is how the casino maintains its edge. That's how they stay in business, right? They get money, charge you for food, and that's it. Okay, well, okay. What if I said, what is the probability you win at least 1? At least 1 game. Okay? You play 3 games again. So play 3 games. what is the probability you win at least one game? Okay, so winning at least one game, this will happen. So winning at least one game is the complement of losing all 3 games. Okay? Because if you think about it, there are only 2 possible scenarios, okay? If you're going to play the game 3 times, okay? Let's say somebody says, okay, I'm going to give you some money, you can play the game 3 times. If you play the game 3 times, there's only 2 possible scenarios. You win at least 1 time, or you lost all 3 times. I don't know what happened either, okay? So that's it, right? You either win at least 1 or you've lost all 3, okay? I cannot think of any other possible outcome after playing 3 games. All right, so we can find this, the probability of winning at least 1 game is going to equal 1 minus the probability of losing all 3. And so we will have 1 minus 0.1458, 0.8542. Is that satisfactory for you guys? Or are there any questions on this? Okay. All right, and so, that covers, sequences of independent events. We'll come back to this later, okay? What we haven't answered, okay? So later, we will say, you play 3 games. What is the probability you win 1? Probability, I'll say you win 1 game. And if you won 1 game, how many games did you lose? Right? And lose 2 games. Okay? So what's the probability you win 1 game and lose 2 games? The answer is not 18 over 38 times 20 over 38 times 20 over 38. All right, this is win, loss, loss. It's not this, but is this thing, 18 over 38 times 20 over 38 times 20 over 38. It's 3 times this, okay? And we'll cover this in a moment. This is called binomial. All right, and this will come later. So we'll get to this later today. So we'll put this thought on hold. So this is what we have. But we've got, what's the probability of losing all 3 or winning at least 1 or winning all 3 or things like that. We've got those. Okay, so now I'm going to jump into chapter 6 here. And chapter 6 covers probability distributions. So with a probability distribution, this tells us for a numeric variable the probability of getting certain outcomes, okay? certain outcomes. For a numeric variable, okay? And so we represent these with what we call density curves, okay? Okay, and so for example, we can have what's called a uniform distribution. So a uniform distribution is an example of a simple probability distribution, okay? And with a uniform distribution, it says every value between 0 and 1 is equally likely to appear. Okay, and so we represent this density by showing from the numbers 0 to 1, you have the height of the curve represents its probability, okay? So the height represents the probability. And so we can see every number between 0 and 1 have the same height. So every number between 0 and 1 has equal probability of showing. Okay, numbers outside of 0 and 1, that height is at 0. Okay, so the height is down here and the height is down here to represent that there's no chance of these numbers showing. Okay, so all the values between 0 and 1 have the same height in the curve, so have equal probability of appearing. Okay. And so one thing to note is that the entire area under the curve is equal to 1. Okay, so if the entire area under the curve is 1, and let's say I draw a line from 0.2 to 0.5. Okay, and I shade this part in another color here, okay? How much have I shaded between, how much is shaded in blue now? Okay, the entire area between 0 and 1, that entire area is 1. So how much do I have shaded in blue if I'm drawing kind of vertical lines at 0.2 and 0.5? 0.3, right? Okay. So the answer here is 0.3. The answer, not negative, but how much have I shaded in blue? 0.3. And so that means the probability that a randomly selected number from this distribution is between 0 and 1. So if I select a random number from this distribution, the probability that it's between 0.2 and 0.5, that probability is 0.3. Okay? So this means if I pick a random number probability it is between 0.2 and 0.5 is 0.3. Is this okay? All right, and so we can, you can have other shaped probability distributions. I don't know, you can have like, we could call this you can have something that looks like this, all right? So this would be like, okay, so you can have, I pick a random number between 0 and 100 2 times. Okay, and I add those numbers together. And you get something like this, okay? So if you pick a number between 0 and 100, so like you pick a number between 0 and 100, first time you get 22. And then you pick a number between 0 and 100, and the second time you get 45, okay? And, between 0 and 100, all numbers have equal probability. If you add those two together, so if I got 22 and 45 and I add those two together, I would get 67, okay? We can say, what is the distribution of the sum? That sum will have this kind of distribution, okay? Okay, we would see this kind of thing where the most common value of the sum that appears will be 100 because there's a bunch of ways to get a sum of 100, okay? And it will be very rare to get a sum of 200. That means the first time you had to pick 100 and the second time you had to pick 100, right? So that doesn't happen very often, okay? And then the sum of getting 0 of 0 it also is very rare because the first time you'd have to pick 0 and the second time you have to pick 0, okay? So you end up getting a triangular distribution, and we can ask something like, what's the probability that you get between 0 and 50, okay? What is the probability that the sum is between 0 and 50, okay? Well, the only rule is that everything has to, the entire area is 1, okay? So if the entire area is 1, we're basically asking how much is shaded right here, okay? And can you guys visually figure this out, or should I help you? Yeah. It's not a quarter. So the area in blue is 1 and 8. Is 1/8 of the total area, so 0.125. Okay. I can I'll draw like dotted lines to indicate kind of how it's. So we can I mean, this is just kind of a loose way. I mean, we could do like calculus and stuff, or some geometry and things like that. But we, basically we just figure out. So how much what is the probability that the sum is between 100 and 150? And what would you say? Like 3/8? So 0.375? Is that okay? So it's just the idea is, how much of the total area is shaded, is, kind of in this shaded region here. So if I were to maybe I'll do a light blue here. And so this is the idea of a probability distribution. Are we okay with this? Yeah? Okay, so then so we have a specific probability distribution called the normal distribution, okay? And the way the normal distribution, the way that thing looks, it looks like this. It looks kind of like a hill, okay? Okay, and so what does this mean? If our probability density curve looks like this, that means, values, so we can call this part right here the center, and because it's the balancing point, we'll just call this the mean, okay? So values near the mean, are they common or uncommon? Are common, because the density curve is the tallest there, okay? So values near the mean appear with the highest frequency. Okay. Where values far from the mean, so out here or down here, appear with the least frequency, okay? Or with lower frequency. The distribution is symmetric, okay? Saying that, values up here, this far above the mean, are just as uncommon as values that far below the mean. Okay? So the distribution is symmetric. So if I were to draw a line at the mean, okay, and if I shade everything, so let's say I shade everything over here. How much have I shaded in? Light blue shaded area, what does that equal? This is equal to 0.5, right? So if I draw a vertical line at the mean and I shade everything to the left, the shaded area is 0.5, okay? Because the total area, as always, for any density curve, the total area is equal to 1, okay? And so the light blue shaded area is 0.5. Is that okay? All right. Do you guys remember what a z-score is? What is a z-score? The z-score is what? Yeah, our distance from the mean expressed in standard deviations. Okay, so what is the z-score of the mean? Yeah, the z-score of the mean is 0. Okay, so if I draw a line at z equal to 0 and shade everything to the left, the area is equal to 0.5. I just want to make sure that statement is okay. Huh? So if I draw a line at z equal to 0 and shade everything to the left, the area is equal to 0.5. Okay? Or another way I can write this is that the probability that I draw a z less than 0, this is equal to 0.5. Is this okay? All right, and so this is where our table comes in, okay? So if you look at your table, and there's two sides to the table. If you flip to the side with the positive numbers, we've got A3, page A3. Let me pull up the normal table, okay? It looks like this, okay? If you look in the top left corner, you see Z, okay? And what this says is that at 0.000, okay? So I'm going to just kind of copy this bit of our table. What this says is that the row is 0.0 and then the column is 0.00. That would combine to z equal to 0.00, okay? So at z equal to 0.00, the area to the left is 0.5000, okay? That's what this table says. That if I draw a vertical line at z equal to 0.00, the area to the left is 0.5000, okay? Or 0.5, basically, which is exactly what we have shown on the previous slide. Sorry, I'll go back, don't worry. Okay, so that's what this picture shows, right? It says if we draw a vertical line at the mean, or where z is equal to 0.00, this area is equal to 0.5, okay, or 0.5000. Let me just kind of slide this up. Is that okay? So what if I take this picture and I just, I move the line just a tiny bit over, okay? So let me, is this the right color I want to do? How do I? Okay, so what if I shift the line over just a tiny bit, okay? So instead of z is at 0, let's say I move it over to z equal to 0.12. Okay, so I move it over, 12 100ths of a standard deviation over to here, okay? So z is now at 0.12, and I'm going to shade everything to the left. Oops, it's the wrong color. Huh? Did I confuse somebody? Okay, so now I've moved the line, the vertical line. It's no longer at the mean, but it's now at 0.012. I mean 0.12. Z is at 0.12. Okay. What is the shaded area here now? It's a little bit more. Okay. And it's this value. Okay. So at z equal to 0.12, I go to the row 0.1, and I go to the column 0.02. These combine to make z equal to 0.12, and the area to the left is 0.5478. Okay, so if I shift the line over just a tiny bit to the right, the area that I've shaded now is a little more than a half. It's 54, almost 55% is what I've shaded now. Is that okay? All right, so if I have 54.5478 shaded over there, how much do I have shaded over here? So one way to write this is I can say the area to the left, I can say probability that z is less than 0.12 is equal to 0.5478. Okay, that's another way of saying the area to the left of z equal to 0.12 is 0.5478. Over here, what is this? This is the area to the right. Of z equal to 0.12. This could be written as probability that z is greater than 0.12. Okay? And what do you think this value is? The complement, right? So I would do 1 minus 0.5478. Is that legible? Okay. And then, so I would do 1 minus 0.5478. and I get 0.4522. All right, why don't we take a 5-minute stretch break here, okay? So I'm looking around and some of you guys are not doing too good, so we'll stop here.